Okay, some students in the office have reminded me that I missed a square here, and they wanted me to just briefly go over this transition from a positive velocity upwards to a negative velocity, a negative acceleration downwards from a positive acceleration upwards. So through time, just to be clear, my acceleration graph through time would be positive 2.8 to the moment that the rockets failed, the engines failed, and then it would drop to negative 9.8 until it crashes to the ground. And these are the two phases. There's phase 1 and phase 2. All right. We need to know, the next part of the question is, how long after it was launched will the rocket fall back to the launch pad? So now we want to know a time. So we know the velocity here, we know the height here, we know the height up there, and now we want to know the time down here. What's T4? Let's use, we need an equation that ties together positions and time. Time is what we want to solve, so we definitely need a time. Let's consider the kinematic equation. X final is equal to x initial plus velocity initial delta through time plus 1/2 a delta t squared. In the vertical direction, our final position here is y4. That's 0. It's right on the ground. There's our origin. Our y initial, we're starting here, is y2. Our initial velocity is v2. That's an upwards velocity that we've already calculated. People should know that. They should have it down. An unknown time. The acceleration from here all the way to the ground is a constant, negative 9.8 due to gravity. And we have another delta t squared. It basically is it's a disappointment to see this. This is a quadratic equation in X. You need to know how to deal with the quadratic equation. You need to be able to use this formula that says if you have an equation of the form a x squared plus bx plus c is equal to 0, then x is equal to, if I remember this correctly, negative b plus or minus the square root of b squared minus 4ac all over 2a. And for us, obviously, to translate this, I shouldn't say obviously, nothing's obvious in this question. X plays the role of t. The coefficient of x is a, which here, the coefficient of, x squared, is 1/2 negative 9.8, put in the units. B is the coefficient on x, which is a coefficient on V2. C is the lone term by itself, y2. You have to use the quadratic equation. One of these answers will be nonsense, the other answer will be the useful one. And so from here, we can find delta t, the time it takes from here all the way to the ground. Total time is going to be delta t plus this 30 seconds here, which was the time it took before the engines failed. So be careful to add those two because what we calculated was just that time. All right. How fast will it be moving when it crashes to the ground? We can use, mercifully, the easiest kinematic equation when there's acceleration. Velocity final is a product of velocity initial taking into account your acceleration through time. We know delta t, we just calculated it here. That's the time it takes to fall. Initial velocity is v2. Remember, it's upward, it's positive. Acceleration is negative, downward. And you can use this value of delta t that you've just calculated above, and you can find a final velocity. It's crashing down, so you're expecting that to be negative. All right, well done if you can do this question.